Okay, we're talking about nitrogen and specifically flushing copper line sets with nitrogen and why we would want to do that. So in this business, we're always using torches, and when we use torches and we heat copper, we create oxidation in that copper. And when we get oxidation in the copper, it's going to flow through the tubing and it's going to get into our orifices and our expansion valves and mix with our oils, and it's just not supposed to be that way. So we have to keep that oxidation from forming, and we do that by flushing with nitrogen. Now this is one of those steps that gets not done quite often. I would say many times, and almost most of the time, it doesn't get done. So what I would like to do is show you how to do it. It's very simple, and also show you why it's so important. So out here on the bench, I've got a torch, which we're not using, but I want you to know it's because of the torch that we need to do this flush. I've got a typical line set size, some 7/8 and some 3/8. We've got a dryer here, just like you would normally have if you were going to install a new dryer or replace a dryer. And then we've got a line set that we've coupled together. This is very common stuff to get brazed together very often in our business. If we just braze them together as they sit on the bench, it's going to oxidize inside. The outside will look the same, but it's what goes on inside that we care about. So it's really this simple. We have our nitrogen, which we all have anyway because we use it to blow drains and pressure test, leak check. When we want to get this nitrogen ready, we want to turn it on and we want to manage a couple of things so that it doesn't build up pressure. Number one, when we turn on our nitrogen, this don't be looking right here. This don't have our face up in here. There's 2,000 pounds of pressure in nitrogen. If something goes wrong with this regulator, I don't want to be right in front. This is where it's going to go out. When I turn on the regulator, I'm always going to make sure that my regulator itself is completely out. And it's not right like you would expect. It's out like this. When it's that way, I have no pressure going through my hose. Nothing's traveling through here yet. As I crank in on the regulator adjustment, you'll hear it. You can hear I'm starting to get some nitrogen flowing through my hose. So I can control that very simply. We don't need a lot. We just need a small amount. If I was going to be brazing this 7/8 line set, and it might be very long, it might not be just this short, I'm going to want to put an adapter on the end of this so I can get a fit. So it pretty much sticks in there and makes a fit. If I don't use that adapter, it's going to siphon in air behind the nitrogen and it defeats the purpose. So now when I crank it up, the very first thing I'm doing is I want to get the oxygen out so I can run a higher volume for a second or two until I've cleared out all the oxygen. When that's happened, and it doesn't take long, I can pretty much back this down to virtually nothing. Okay, now all that's in this piece of copper is nitrogen. Nitrogen is inert and it won't oxidize. So I would make this braze right now. And when I got done, it would stay clean. And I'll show you an example of that in a second. A piece of copper this small, smaller, which is 3/8, I might not need the adapter. I could stick it all the way in. I would do the same thing. I would flush it through. Of course, don't forget, we would always protect our dryer with a damp rag. And then I would make my brazes. And then I would also leak test it. Turn this back off. Now I just want to show you just a quick example before I show you the machine behind me. This is a piece of copper that has not had nitrogen flown through it. So look at the outside. The outside looks the same. This is what happens when you braze it. When we don't flow nitrogen through it, we end up with all this black scaly oxide on the inside. Here's a piece where we did flow nitrogen through it. Looks the same on the outside, but look at the inside. Basically, it's still like a new penny on the inside. It was exactly the same. These two got brazed on the same day, the same time. One of them, no nitrogen flowing through it. This one, nitrogen flowing through it. Now this should make a believer out of you. You do not want that oxidation in the copper. Now if I was going to apply that to a line set like behind me, it's still very simple. Turn it off, disconnect my hoses, let me move my tank, Now, I've got the tank in place. I've got a hose hooked up to both sides of my lines, basically my high and low side. I'll tell you why here in just a second. I would hook up my nitrogen, I would turn it on, and I would start it flowing. Now it's going to flow through one side of my line set, and it's going to want to come out. If it doesn't come out of the line set, it's going to pressurize the line set. That's going to defeat two purposes. It's not going to flush out the oxygen that might be in there, and it's going to build up pressure. If I build up pressure in my line set, I can't braze it. So I have to have an escape path. In this case, I've got my blue hose hooked up to the other side of the line set, and it's just open to the atmosphere. So the first thing I would do is flush this, let it come out the blue hose. After I was satisfied that I got all the air out of there and it was full of nitrogen, I would probably go ahead and shut my nitrogen bottle off, just because I want to make real sure there's no pressure in my line. Then I would proceed to do whatever it is I'm here to do. Braze in a new dryer, add a side glass, change the expansion valve, fix a leak. Whatever I was going to do, I would do with line sets full of nitrogen, but not pressurized with nitrogen. That's the important part. When I was done, I would go about a normal leak test like we always do, and I would always make sure I put in a new dryer every time I open the system. But if we flush our lines with nitrogen, and we do it every time, we will keep the inside of our copper looking like this, which is what the manufacturer wants and what equals long-term life for the unit.